Although many scientists believe that climate change is already having an impact on our social and economic systems, much of the debate on this issue balances the actions of current individuals, governments, and companies with the effects of these actions on future generations. Inherent to this conversation is that human beings value the present differently than the future. An economic approach to quantifying the difference between present and future outcomes is the idea of discounting. In this video, I'll demonstrate how to calculate the present value of some future cost or benefit using discounting. Then I'll relate this idea to sustainability decisions. To motivate the idea of discounting, let's consider a lottery. In some states, including New York and New Jersey, a lottery winner can receive the full jackpot, but spread out over several years. Alternatively, the winner can receive a lump sum payment up front, but in this case, it will only be a portion of the jackpot. Suppose you win the lottery and you're choosing between either a $5 million lump sum payment or $1 million per year for 10 years. Which option would you choose? One way to evaluate these options is through time discounting. Time discounting is the idea that a benefit we receive today may be perceived as more valuable than the same or greater benefit sometime in the future. We can explain this discounting in two ways. One is a strictly financial argument. We actually gain more from the benefit today. For example, we could invest the money and let it grow over time. This is the motivation behind the lottery, as the state lottery system doesn't actually have the full jackpot, but rather plans to invest the pot to reach the full jackpot over time. But even beyond this strictly financial perspective, we have a desire for immediacy, so that receiving a benefit or suffering a cost today has more weight for us than something that occurs in the future. We can quantify the idea of discounting in the following way. Recall the exponential model of growth we saw earlier in this semester. Suppose you have an investment with value P and you expect it to grow at a rate of R% per year. Then in N years, the investment should have value U. We can work backwards from this formula to determine the present value of some amount of money in the future. Suppose you expect or want to have a value U N years from now. Let's suppose we also have an annual discount rate D. Then, substituting D for R and solving for P, we get this equation. For small values of D, which are typical for discounting, this formula is closely approximated by the second. This is our discount formula. As an aside for those of you who have taken calculus, this second equation, the approximation, is the tangent line approximation, or the first Taylor polynomial, for the original formula. Let's apply this to the lottery example. Here, I'm assuming a 10% discount rate. This corresponds to the average annual growth in the stock market. You get the first payment immediately, so its value to you is just $1 million. You receive the second payment in 1 year. So to compute this present value, we have P is equal to 1 times 1 minus 0.1 to the 1. And this comes out to be 0.9. Here, the first one represents the original $1 million payment. The 0.1 is the discount rate. And this one up here represents N equals 1 year in the future. This calculation shows that the $1 million payment I get 1 year in the future is only worth $900,000 in today's money. We can do the same calculation for the third payment. Here we compute P equals 1 times 1 minus 0.1, all raised to the 2, since this payment will occur in 2 years. From this we get 0.81. In other words, the payment 2 years from now is worth only $810,000 in today's money. I've done similar calculations for each of the 10 payments. Notice that the final payment, which I would receive in 9 years, is worth only $387,000 in today's money. Adding up all of these calculations, I get $6.5 million. That is, the 10 annual payments are worth about $6.5 million in today's money. This calculation suggests that, from a strictly financial perspective, it is worth more to take the annual payments rather than the lump sum, even taking into account significant time discounting. In actuality, most lottery winners choose the lump sum despite the financial benefits of the payment over time. Here, I've shared information from a 2019 report predicting the future impact from climate change under various scenarios. The first models a 2.8 degrees Celsius rise in temperature, whereas the second models a 4.5 degree rise. The researchers estimated that the higher increase in temperature would result in an additional $224 billion lost to the U.S. economy annually by the end of the century. How much should we be willing to pay now to reduce future temperature rise from 4.5 down to 2.8 degrees Celsius? Note that these are annual costs and so accrue to much more than $224 billion. However, to simplify calculations, let's just consider the present value of the economic impact in the year 2100. This is 80 years from now, so we have n equals 80. Let's use a discount rate of 5%. Then we have P is equal to 224 times 1 minus 0.05, all raised to the 80. This comes out to be 3.7. That is, it would make sense to spend $3.7 billion now to offset the future harm to the economy. Again, this only addresses 1 year of damage to the U.S. economy, so the total financial impact is actually much greater. In the previous scenario, I picked a discount rate essentially at random. Picking a different discount rate would certainly affect the present value calculation. How should we select a discount rate? Over short time frames, and when costs and benefits can easily be put into economic terms, discounting isn't controversial. In the lottery example, I used the historical growth rate in the stock market, which we might expect to roughly continue for the short-term future. However, over longer time frames, the discount rate becomes less about how the economy might actually grow and more about how we value events and individuals in the future. That is, over longer time frames, the choice of a discount rate becomes an ethical choice. This is especially relevant for climate change, given that our actions today involve mainly long-term benefits and costs.